Assalamualaikum and good day, student. It's lecture 7. Words of wisdom for today. A bit brief review on lecture 6 on the relative motion analysis. I believe you already familiar with the equation. So this is the motion analysis on the dependent particle. So what we will discuss today is mainly on the kinetics of particle. So you need to understand the general Newton's second law, and then how to interpret or analyze the motion, the particle motion in x, y coordinate system, and also how to analyze the particle motion in anti-coordinate system, and also how to analyze the particle in r theta coordinate system. So what is the relationship of force and acceleration? So this is the second Newton of law, where force is equal to ma, where m is mass and a is acceleration of the particle. Taking an example, this is the green particle. It's been induced by the external forces F1 in the red arrow direction. So of course the particle will have an acceleration in the same direction of the external forces. Same applied if we induce another external forces F2 with a different direction, and then probably there is another external forces over here, F3. So how, if let's say the combination of F1 until F3, so what is the resultant forces that we can analyze? So let's say there is the green color is there is a particle over here. It's being introduced by external forces 1, external forces 2, and external forces 3 with a different angle. So this is the direction of F1, this is direction of F3, this is direction of F2. So what is the resultant forces and resultant acceleration? If we are using the drawing with a very good scale, using the magnitude of external forces F1, and then using the same direction according to here. So and then we draw the F1, F2 and F3 according to scale. So actually the line from F1 to the arrowhead of F3 is actually representing the resultant forces, and then again the resultant acceleration is at the same direction of resultant forces. Okay, it means that the resultant forces is actually the sum of forces is equal to ma, where a is the acceleration over here, m is the mass of the particle. This is the sum of external forces F1, F2 and F3. How to analyze the motion in x and y coordinate system? Taking an example, there is a slanting plane or floor, and then the block is sitting nicely at the slanting plane. The block is being introduced by the external forces F1, F2, and F3, or F4, F5, and F6, dan seterusnya lah. We have to draw the X and Y axis. So taking an example, we are drawing the X axis at the surface of the plane over here. This is the X axis, and then perpendicular to the plane is the Y axis. So what we need to do is that the resultant forces, because we are now want to calculate the resultant forces. So dalam first topic on the chapter 1, you dah tahu macam mana nak break all those say that masa tu adalah velocity kan, velocity or acceleration in X and Y coordinate system. So same applied to this topic. We can say that resultant forces is actually, kalau kita break pada matrix, so it's actually the FR X, force acting, total resultant forces acting at X axis and resultant forces acting at Y axis is actually sama dengan resultant forces of 1, yang nombor 1 tadi, at X axis, and resultant forces of 1 at Y axis plus subcomponent of F2, and then plus, if like say, the F3, F4, F6 until the last numbers, is actually equal to M, the mass of the block, times the acceleration of the block at X axis times the acceleration of the block at Y axis. So the equation will be something like the sum of external forces at X axis and the sum of forces acting at Y axis is actually equal to MA X and MA Y. So this is another way of rephrasing the symbol. So you know that X is position, X dot is a velocity, and X double dot is the acceleration. So this is equation only on the X axis. This is equation at Y axis. So jumlah external forces yang bertindak pada paksi Y adalah sama dengan mass of the block darab acceleration yang bertindak pada paksi Y. So that is the explanation. In trajectory system X and Y vertical, in trajectory, so we know that the total forces acting at X axis tak ada kaitan dengan gravitational. So we can say that the total forces acting at X axis is actually MA, where A is tak ada acceleration yang bertindak because of the gravitational forces is 0 at X axis. So that's why the total forces acting at X axis is equal to 0 compared to the Y, to the Y axis, where it's actually jumlah external forces yang bertindak pada paksi Y adalah sama dengan negative mg, kalau you masih ingat on the trajectory. Okay, what about the anti-coordinate system? You know that in any cases where particle move in a circular path, so this is the circular path, akan ada satu force ataupun acceleration acting, number one, to the tangential of the curvature path. Another one is acceleration acting to the center of curvature. So here, let's say there is a continuous external force acting tangentially, so we can say that jumlah forces acting tangentially adalah sama dengan MAT, mass of the particle darabkan dengan acceleration tangential. Begitu juga dengan the forces acting to the normal, to the center of the curvature adalah sama dengan MAN, mass times A acting to the center of curvature. So in equation we can say that resultant forces yang berlaku pada partikel ni semasa dia bergerak secara curvilinear adalah sum of external forces yang bertindak pada tangential, and then jumlah forces yang bertindak pada normal axis adalah sama dengan M in the metric form times AT, acceleration tangential dan acceleration normal. You tahu in tangential is actually this one, MA. You tahu sebab you tahu AT is equal to R alpha, because alpha ni sebenarnya adalah angular acceleration. So you just replace the MAT with the MR alpha. Same applied to the equation at normal axis. So you tahu at normal acceleration, this is AN. You tahu that this is AN. Okay. And then you boleh simplify the equation either using mv squared over r, or you can replace with the r omega squared. For the r theta coordinate system, actually the particle is moving radially, dia bergerak secara radial ke atas, and then at the same time dia punya degree ni berubah-ubah. So what we can explain is the jumlah forces yang bertindak radially adalah sama dengan mass of the particle times acceleration radially, yang in the direction of radial, because this is particle, this is the center of curvature at an instance, while untuk yang theta, sebab dia sentiasa bergerak at a certain position, the angle ni akan berubah-ubah. So what we can say is that jumlah forces yang bertindak pada sudut ni adalah sama dengan mass times acceleration pada direction theta. So this is actually the angular velocity. This is angular acceleration. So this is the equation, sama juga, jumlah resultant forces in matrix form, jumlah component of external forces at a theta, and then jumlah external forces yang bertindak pada radially secara jejari, dan sama dengan m times acceleration pada waktu sudut ni, and then acceleration secara radially. So this is the bukan say simplified, the expansion of the equation. So actually this one is representing a theta, and then this is a radial. You can refer to any textbooks or any other references on the application of r theta coordinate system. Then you may further understand the working principle of r theta coordinate system. Okay, what is the forces to consider? One is external forces. Number two is forces generated by motion. Number three is forces generated by gravity. Four is forces generated by touching surface. And then forces generated by friction. So this is example of external forces. Again, this is a simple one. There is a lorry, there is a man. So man is giving the external forces to the lorry. Memang kuat betul lah orang. So dia tarik, and then lorry tu akan face a motion. Dia akan bergerak lah because of the external forces yang di-induce oleh orang, those men tadi tu lah. Force generated by motion is actually the forces yang disebabkan oleh sesuatu pergerakan. In these cases, force yang terhasil akibat pergerakan in a curvilinear motion. Okay. In this case, kita akan ada satu force acting towards the center of curvature line. Kalau you tengok pada kereta ni sebenarnya akan menghasilkan, jika dia bergerak pada curvilinear path, dia akan menghasilkan satu force acting to the curvilinear to the center of curvilinear path. Force generated by gravity is actually, this is a simple one. You know that there is a weight of the block, so that is the force generated by gravity. It's always vertical direction. And then force generated by touching surface. So in any cases of touching surface, kita akan ada satu normal forces acting perpendicular to the touching surface. Okay, perpendicular to the touching surface. And then force generated by friction. This is due to the coefficient of friction of the surface. So in any cases of a block in a slanting plane, let's say, is having a acceleration at the right hand direction, and then there is external forces acting over here, pulling the block downwards. So by the time the block is moving, there is a frictional force over here because of there is a mu, the coefficient of friction, either mu k or mu s. Coefficient of friction at kinetics and coefficient of friction static. So this is the graph of external forces plus frictional force. So this is the maximum. This is actually mu s, and then this is mu k. Coefficient of friction static, coefficient of kinetic friction. This is static, this is kinetic. So the combination of all forces let's say we take a car over here. Car have a weight, and then the car is moving at a curvilinear path. That is a normal forces acting, and then there is a normal forces acting to the tire, both tire, and then there is a frictional force acting because the track is a bit slanting, so the force is tend to the car is tend to sliding down, but there is a frictional force acting on the opposite side. So the combination of forces, weight, force acting to the center of curvature, and then the normal force, and then combine with the frictional force. So this is the combination of all forces acting at the car while moving at the slanting road in a curvature path. So you can check your understanding over here. You can pause the video and do some simple question.